Just let me know if you have a question. So today we will go over the dispersion in the shape and finish our first chapter slides. If time, you go Excel, or if you have time, you will go to the quiz. Depend on the time. Okay, maybe let's get started because I think it's already past the time. So let's get started. So just a very brief review of what we covered last time. It just very standard thing, the central tendency, which is the a number that try to represent whole data set. So what we learn is mean, median, and mode. Okay, mean just very simple. Adding all the numbers up and then divided by the size of the observation. And median will be just the middle data, and the mode is the most frequent data. Okay, so before we start, any question? Any question? Okay, no? Okay, if no, then we just continue with what we call dispersion. So dispersion is related to how you can say how accurate our mean measure is, right? So mean is the most commonly used measure for central tendency. So the question would be like, what would be the best measure for the mean, right? Is it mean accurate at all, right? Because we want to have something to represent the data, but we really want to have some to know how accurate it is, right? How representative of the mean. So that's what we would like to see is the it's called dispersion. Is how the data is away from mean in some sense, okay, or away from the mode or away from median, okay. So that is the idea. If you assume the data is symmetric, which we'll define later, right, that will be the mean, median, mode at the same place. So that's why dispersion is asking if the data is symmetric about the mean, then dispersion is measuring how accurate is the mean, median, and mode, okay. So let's get started. The very easiest one is the range, okay, the range. So the definition of range is very simple. Just find the biggest minus smallest, okay? And that shows how accurate the mean is, right? Because the mean is in the middle. And if the range is large, then by definition, it would be far away from the mean, okay? And the main drawback would be affected by outliers, right? As you mentioned last time, right? If very rich people, say the income data, very rich people like Li Ka-shing will be affecting the range a lot, okay? But this is one of the way that we use to look at the data. So let's see the example. So you can see the first one, 1, 2, 3, 4, 5, right? And then the range will be, the biggest is 5, the smallest 1, so it's 5 minus 1, so it's 4. And the other example is 1, 2, 3, 4, 5, 50. And you can see the difference, right? The largest minus the smallest, right? That is 50 minus 1 is 49. So you can see even though the data itself is, the first 4 observations are the same, but the last one is different, then we will see a very different result. The range will be much larger. And as we see the example before, the mean here is really representative, but this one is not that much because you can see the range 49, okay? And that is compared to all the data here, the first 4 data means, right, the range is much smaller, right? It's between 1 to 4. So definitely you can see the mean is not a good measure for the second data set, but it's okay for the first one, okay? Any question? No? Okay. So let's go to the next one. So this is rather simple. So let's see the next one. So the next one is what we call the interquartile range. So it's not the range. Range is, maybe it's good to draw a picture on it, right? If you have data set represented by a number line, right? Suppose it's a number line, right? And this is the smallest, okay? And this is the largest, right? And this is what we call the range, right? And the data can be, this is the biggest data here, this maybe it's under color, right? Suppose this data point is here, another data point is here, right? And there's some data point here, whatever, that may be here. Okay. So the data here, okay. So this is the range, but as we said, if this data point move further or this move out of the way, then the range become large, right? So we want to be less affected by these 2 extreme value, right? And very often these 2 extreme value often cannot be measured accurately, as we said, right? Just like income or the wealth of recasting, what we probably don't know actually what's the income, right? So what usually you would do is instead of using the range, you use other way around. So instead of the range, we will use what we call the interquartile range, somewhere in the middle, okay? But what is measured in the middle, what does that mean, right? What does that mean in the middle, okay? What we're going to do is to divide the data into 4 parts, okay? That is called the quartile, okay? So basically the data is like this, right? This is the mean, this is the max, right? And the middle, right? We know is a median, right? And if you take the first half and do the median again, okay? This is what we call Q1 or the first quartile, okay? And if you do the second part, find the median again for the second part, this we call Q3, third quartile. Quart means 4, okay? Tile means part. Tile is, you can see tile is this rectangular shaped stuff, right? So this is Q2. And sometimes people refer this to Q0, and this is Q5, sorry, Q4, okay? So that is the idea behind, and what we want to measure instead of measuring this as a range, right? This is called range, right? But now what we want is what we call the IQR. We will define later, but this is interquartile range. Okay, this is the idea. And as we here intuitively, we said we find a median and look at the median again, and here median again, right? But this is only one way to figure out the first quartile and the third quartile, right? And more formal definition will be, remember, median is defined as half of n plus 1, right? Rank data. So the quartile will be 1/4 of n plus 1, and the third quartile is not the same. Sorry. So here, median or the Q2 is easy to define. Later you will see Q1 and Q3. Actually, there's a tricky part to define in practice. At least when you have finite number of data, there's no universal way. And the reason I want to mention different way because different software package will give you very different result. So that's why you really need to understand why we have that. Okay. Is there any question before we talk the formal definition? This is the idea. Divide data into 4 parts and look at the boundary of the first and second half is Q1. Boundary of the third and the fourth will be the Q3. Is that a question? Okay. Okay, I hope that is okay. Okay, good. So then I erase the board here. Then the definition, as we just said, is a Q3 and Q1 difference, right? So, and the important is legs are affected by outlier, as said, because look at the middle, right? So that's why if outlier is not in the middle, so it don't really matter. If the outlier is in the middle, then it's an outlier, right? Because outlier means the extreme value, so it's not an effect. So let's go to the next slide. Okay, so there are many methods, okay, and probably what you learn in high school is a little bit different. So there are 2 methods. First, the 2 method is involved using the median, okay. The first 2 method is related to median. So this method 1 and method 2 are using the median. And method 3 will be using what we call the quantile function, okay. Quantile. So do note that it's a quantile, it's not the quartile. So it's not the quartile. Okay, it's not quartile. It's a quantile. Okay, quantile, not quartile, quantile. Okay, so but our percentile function. Anyway, so how we find the Q1 and Q3? Okay, so one way to do is what we have defined intuitively, use the median method, okay? Use the median method. First, what you do is to find the median first, okay? Find the median, okay? We know how to find the median, right? If the number of data is odd, right? Then exactly the middle would be exist in the center, right? Just like you have 3 numbers, right? The middle is exactly the second one, okay? You have 5 observations, the middle is the third one, okay? It's n plus 1 or 2 is if odd, then you have exactly middle, okay? And if the evens, okay, then will be then will not be data, okay? So the way to do is, suppose you have 5 numbers, say, suppose, or to illustrate Q1, okay? You have 5 numbers. Then the median will be this guy, right? And what you do is you include the median into the 2 halves. So that means that the first half will be the first 3 number, okay? And then from this half, you find the median, which is this guy. So this guy will be Q1, okay? And for the second half will be this one, because you include the median itself, okay? And let's use the purple color. Sorry, still the green one, maybe better. So this will be Q3, okay? So that's the way you find Q1 and Q3 for the odd number, sorry, for the even number, so odd number of data. If you have even number of data, then it doesn't really matter, right? Suppose you have even number of data like this, then the median is here, okay? So the first half is these 2, and second half of these 2, right? And the median come in here with average of 2 with Q1, and average of this 2 with Q3. 3, okay? So that the difference doesn't really matter, okay? That's how you do the method 1. Don't worry with example later, but this is the idea, okay? And for method 2, okay? Method 2 is the same when you have even number observation, so the same thing, okay? So what's the difference? Is this guy, okay? Is in this case, method 2 we said, oh, the median is here, okay? But we shouldn't include the median. So that means that this will be the thing to calculate Q1. So it will be here, Q1, okay? And in this case, Q1 is here. The Q3 is here, calculate here, okay? The median will be excluded from the 2 halves. Is that okay? Maybe before we proceed to the third method, let us go through the example first, because that would be more easier to understand. Yes, different method. That's why let's show you the method. So suppose you have the data. We have 1, 2, 3, 4, 5. Why do we need two definition? Because of, as I said at the beginning, different software will give you 2 different methods. Say if you use Excel, will give you other one, and then the other one give you other one. So the reason is you have to understand what is the method, and otherwise you don't know how to compare. Say suppose you use data, we give you one method. Use R, give you another method. Use SPS, give you the method. Then you don't know which one is correct, right? Then you need to what's more accurate. Usually, if data is large, doesn't really make a difference. And usually, as I later will said, the third one is better. Okay, this number 3 is better. Okay, and the reason why I said 1 and 2 is because 1 and 2 usually you learn it in your high school, and if you use the scientific calculator that 1 and 2 will give you, and 1 and 2 usually will be easier to see because you find the median again. Usually it's also easy to operate. And the third one is a little bit more elaborate. But now, of course, if the computer software, it doesn't really matter which one you do, but you need to know which one should be the most appropriate. And indeed, you look at a lot of statistical measure. In fact, there are many ways to do it. Okay, there's no one way to do the thing. If you later learn Excel or Python software, there's a many ways to do the same thing, right? Just like you can join this class using your laptop, using your desktop, using your cell phone. Which way is better depends on where you are, right? And depends on what equipment you use. And there's no easy way to tell which one is which. But for our purpose, and we want you to use method 3. As for exams or assignment, then we should use 3 because 3 is the standard way used in the advanced study. Okay, so if you ask me which one's better, I would say number 3 because of this is shown to have a nice property. Is that okay? I hope I answered your question. It's a bit long, but this is a overreaching idea of one way have there are different ways to measure the same thing. Right? Just like you ask me whether mean, median, or mode, right? They are all the central tendency. Which is better? Yeah, but depends on scenario, right? Mean is easy to calculate. Median is more difficult to calculate, but sometimes it's good, right? But do not have much nicer property or much more complicated to calculate. So that's why we focus on mean. And mode is sometimes is good also. So it really depends on situation. Usually, as we said, I mean, you don't restrict to one, right? Because you can calculate everything in the software. So usually, at least in research, internal research, whether you show your clients or not issue, but for your own purpose, study purpose, you should do all kind of calculation to see how things work, right? Many of you are doing accounting, right? So, and accounting, you do a lot of ratios, right? And you may ask which ratio is good, right? I mean, maybe the liquidity ratio, the many, right? I mean, look at the company. You have a current ratio, you have a quick ratio, the many ratios, right? I mean, which one is better? I mean, that would be up to you to design, right? Same as a lot of things. Is that clear? Okay. If no, then let's look at the example. Okay. So example 1, we have 5 numbers, 1, 2, 3, 4, 5. Okay. Well, we clearly the median is 3 because you count on both sides. 3 is the middle. Or using the formula n plus 1 over 2, which is 3. The third item is 3. Okay. And method 1 said you will include the median into the half. Okay. So the first half will be 1, 2, 3, right? Because this is the first half, 1, 2, 3. And 1, 2, 3, the median will be 2. Okay, so that's why Q1 is 2. 3, 4, 5, the median is 4. Okay, it's 4. So that's 4 minus 2 is give you 2, the IQR. But the second method, which shouldn't include the median, will give you a different result. If your median is 3, the first half will be 1, 2 because you don't include the median. Okay, and the second half will be 4 and 5. The median will be 4.5. So the difference will be 3. So that's why IQR gives you different result. Okay, so give you another example. If you have 6, okay, and in that case, the median would be, the two methods give the same result because the median is not included in the data, right? The 6 observations, the median is in the 3.5 observation, so it will be the half of 3 and 4, right? So that would be 3.5. So you follow this method, you figure out the Q1 and Q2, Q1 and Q3 are 2 and 5. So that's why IQR is 3. Okay, so, but in this case, the two methods are the same. Is that okay? Oh, sorry, I should send everyone. Is that okay? If you don't follow, we can just repeat a little bit, but I hope that is okay. Good. So let's look at the last one, which I would recommend this one, and I think that we should use this one for our exam or our practice. Okay. So first, let's define what we call the floor function. I mean, actually, we have talked about this floor function, right? Which is saying if you have a 3.5, okay, the floor give you 3, okay, 3.9 give you 3. So basically just a round down, okay, just a round down function, just a round down, okay, round down to integer, okay. And what we want to do, look at this, is looks complicated, okay, but look at the following. So suppose you want to do, so let's first define the quantile function first. Okay, this is a definition independent of the first quartile, third quartile. Quantile is a quantile function. Okay, this quantile function is the following: P is a value between 0 and 1. Okay, when Q of 0 will give you the smallest data, and Q of 1 will give you the largest data, okay? And when P equal to half, then will be the Q2 is the median, okay? So the first thing we know the median, okay? So the Q1 will be 1 quarter, Q3 will be the third quarter, right? Basically, you just divide data from normalized to 0 to 1, okay? And if what we want is look at this function, okay? So you look at the P, okay, is 0.25, okay, which is the 1 quarter, right? So remember what we want is n plus 1 times p, right? That's the idea, right? Because we define the median is half of n plus 1 rank, right? And the first quartile is 1/4 n plus 1, right? So this is the Q1. Okay, that is the definition. Okay, so actually then what we want is look at the round down function. Okay, round down, and then it will be xk, right? Suppose k, right, is 3.5. Okay, so not the k, but should be p times n plus 1. Okay, let me erase a little bit. So suppose the p times n plus 1, okay, is 0.25, okay, is 3.5, okay. Then you do the integer function, okay, give you 3, okay. So that means you give you x, the third observation, okay. And the alpha will be difference, okay, between these two. So what you filter out, which is 0.5, because 3 minus 3.5 minus 3, which is 0.5. Okay, so we take the integer part, take the number out, and take this 0.5. Then you will be x4 minus x3. Okay, so this formula looks a little bit crazy. Okay, and you may not notice why that's the case. So suppose this is x3, this is x4, right? Now it's 3.5. How you calculate x 3.5 here? Okay, that is actually is the Q1, right? How can you do that? Actually, what you're doing is doing the following, right? Just is is what you learned the high school math. Actually, it is like this, right? It's half 0.5 here and 0.5 here, right? So you just 0.5 times this and 0.5 times this, right? That is how you do how you divide it into half of half, right? So you cancel this out, right? You rewrite this, right? Actually, we give you 1 minus alpha xk times alpha xk plus 1, right? This is exactly the same formula what we learned, right? If you have xk plus 1, and you try to divide it into alpha 1 minus alpha, you just do the cross multiply, right? That's what you learn in the high school. But of course, if you don't want to know the intuition behind, doesn't really matter, because this is the formula. You just apply it and that's it. But the idea is what you learn in the old days, how to divide a line segment, right, into a ratio of alpha to 1 minus alpha. Okay. So let's define it. Still, probably you would be not familiar with the formula, but learn example, things will become very intuitive. Okay. So here we have is n is 5, right? So the k will be q1, okay? Q1 corresponding to p is 0.25, okay? So that's why k will be 0.25, n plus 1, okay? 6 times 1.25 gives you 1.5, and gives you 1, okay? And the difference between 1 and 1.5 is alpha, right? So then what we have is the x of k, which is x1, times alpha, okay? Xk plus 1 is x2 minus x1, okay? So x1 is 1, half, 2, second data, minus 1, okay? So that's why we have 1.5, okay? So for Q3, okay? For Q3, P is, y alpha is 0.5. Alpha is basically, you have this number, 1.5, right? And this is 1. The difference is 1.5 minus 1 is 0.5. And just go back a little bit. The difference between the original number and the number we round down. Okay. So here is 0.75. So if you question, feel free to leave the chat. Otherwise, I don't know. I'm not sure whether I lost you. So it's 0.75 n plus 1. You can see 0.75 is 4.5. Okay, and 4. And the difference is 0.5 here. And you have the number of data, okay, which is 4, and alpha, okay, and then the difference between the 4 and 5, okay, so give you 4.5. The difference is 3. So in this case, they're the same, right? Method 2 and method 3 the same, okay? So that is the idea. Looks complicated, but when you work a little bit more about this, then you know. Okay, let's work out one more, okay? One more out, okay? So Q1 correspond to P equal to 1/4. So that's why we have 1/4 here. And N, we have 6, right? N equal to 6. So that's why I have 6 here. And 7 times 1.25, right, is 1.75, right? And you round down is 1. The difference between 1 and 1.75 is 0.75. Okay, this is alpha. So alpha just end up here, right? First one, xk is x1, and x1 is here, and it's 1 plus 1 is 2, x2, okay? So that's why it's 1 plus 0.75, 2 minus 1. Okay? And similarly, do the same, but instead of 1/4, you do 3/4 for P. Okay? So 3/4 times 7 is 5.25. Okay? Round down become 5. The difference between these two would be 0.25. Okay? So the fifth and difference between fifth and the next one. Okay? And you take the 0.25. Okay? Then give you the 5.25. Okay? The difference is 3.5. So you can see this is very different from the above. Okay? And usually we think this is more accurate, as we have mentioned, because this one has a summarized property here, which we don't study why, but usually this one is something usually we refer to when we talk about quartile interquartile range. And when the data size is large, actually doesn't really that matter. When you have say 1,000 or several 10,000 people, usually doesn't really matter. But when you have smaller data set like hundreds, then probably you want to use this one. Okay. Any question? I mean, of course, there are many more indeed. I mean, I'm not showing you every case of the. Sorry, I'm not saying this is every cases, but that is one way three common we can do it. There are more ways. IQR is interquartile range. Yes, is trying to check if central tendency is accurate. That is called dispersion. Because Q2 is the median already, we are trying to see, because the idea is, as we said, right, the larger than smallest is the range, right? But the range is not that accurate because of the outlier. So we want to figure out how disperse the data, how different data. Then instead of using the big and the biggest, smallest, why don't we use the first quarter and the third quarter data? Okay, that's why we use Q1 and Q3 here. And why we don't? Someone asked why I don't use the median. Maybe one of the way you may ask, okay, why don't we may use median in some sense, like I don't know, maybe you have to median to somewhere, right? Because median or the middle, so you have to measure some way here and here, but I'm not sure how to use median. Why method 3 is different? Because different method will give you different results. So it's definitely not as, I mean, even in the previous case, method 1 and 2 are different. Okay, so the free method doesn't have the same result. And as I said, there are at least, if you look at the software package R, at least there's a 9 method to measure there. So there's no one single rule that is better, but As I said, method 3 is the most common one. Okay. Method 3, what the advantage? Because of you don't have the integer problem, because you have to find the median first and find the two median. So it's not exactly because we want exactly the quartile, right? We want exactly the one the 4 part and exactly that part. So I don't know where's the correct answer, but usually that is the answer people use. Because basically Q1 and Q2 is more like, as I said, yes, exam assignment, we just use method 3 because just to uniform, because otherwise hard to grade, right? So that's why I use method 3. Of course, in your project or site, I mean, if you can say I follow this method to define IQR, you can do two way. But I think if you do actual project, doesn't really make a difference. But people will use method 3. If you don't say anything, people usually assume you method 3. And 1 and 2 is more like historical thing. Okay. Is that clear? Because sometimes you go to calculator, you have one result, you go to other calculator, other results, and that's very often. That's why we need to discuss this. Don't worry. I mean, for the next few measurement, you have a somewhat uniform formula. So only this IQR is a little bit trickier. Okay. Good. So let's clear the board. So if there's no problem, so we talk about something very easy to calculate. It's called the variance, and it's friend or his you call the standard deviation. Okay. As we said, we want to measure is how accurate is the mean is, right? Is how good the mean is, right? So we didn't use the mean, right? Most of the time. So the variance basically use the mean exactly. Okay. So what this variance is we want to measure how accurate the mean, right? So the easiest thing is to have the difference between the mean, okay? The difference from the mean, right? So basically, if we have a lot of data, okay, assume there's a data line, so some more data, right? Okay, and the mean is somewhere here, okay? And what we are measuring is we try to do is why don't we just look at the distance between the mean, right? The distance between the mean. So this is how accurate the mean, right? If it's different from the mean a lot, then it's not so accurate, right? Look at the distance, right here and here. Every observation you calculate distance, right? And if you do so, that is you try to do the summation xi minus x bar, okay? This actually gives you 0, okay? The reason why you have seen this is because the mean is in the center. So the data sometimes above, sometimes below, add all up will become 0, okay? So add and more up is not a good measure, okay? Because plus and minus will cancel out, right? So one way you can imagine is, why don't we do absolute value, okay? Absolute value means everything become negative become positive, okay? So you have a problem. You add all the positive one, okay? Yes, this is a good measure. And indeed, this is also used, okay? But the problem is calculate absolute value. There's some difficult issue in the math, okay? But recently, you know the computer one, so that's why now this is also a good measure, okay? But in our class, we don't talk about this. Instead of the absolute value, we use the square, okay? Use the square, okay? And you may ask why square? We don't have, because need not be square to cancel out, right? You can use the raised to the power 4 or 6, right? But raised to the square will be somewhere easy to do, right? Because you raise to the power 4, and in the old days, right, the calculator not easy to calculate, right? So that's why you just raise to the power 2, just for practicality. And indeed, square actually turn out to have a nice property. So that's why everyone do the square, okay? And because also you don't want to be affected by the number of observations, so that's why you divide by n, okay? And that's why we call this variance, okay? It's called variance, okay? And this is called sigma square x, okay? It's adding all the observation minus the mean and take the square. So every observation with the square difference, okay, always positive, and then more divided by n. Or because you add all up the n, it's called the average distance from the mean, okay? But of course, you square, so average squared difference, or we call distance. The same thing here because we have a mean, okay? And if you look at the textbook or look at somewhat otherwise online, then you will see it's not n, but n minus 1, okay? Then you see n minus 1, then it's weird, right? Then it's no longer average, okay? It's no longer not an average anymore, okay? Or the mean, right? There's a mean distance from mean, okay? And the reason why we want to have over n minus 1 to n is we will learn it in the chapter week 6, where we learn estimation. That turned out to be n minus 1 is a more accurate measure when the sample size is small. Okay, so when you look at we call the sample variance, you'll be using S, okay, instead of sigma. And if the data is more than 1,000, doesn't really matter. Okay, when less than thousands, somewhat accounting classmate we're doing, we have to do sample. If you for finance classmate, you're doing time series stock market data, then sigma or S will not make a big difference. But you need to know we're talking about this is the population because population variance. This is called sample variance. Okay, and what is mean population? What is the sample? Population is the thing we want to study. Sample is a part of the population. Okay, something like this population. Okay. And we take something out. This is called sample. Okay. And we will discuss this terminology later when we talk about sampling in week 6. But for the moment, just what we call sample counterpart means there's some adjustment factor. Okay. Here in this case, it's just multiplied by n over n minus 1. Okay. And later you will see in Excel, we will hopefully have time today. We will call variance P and variance S. Variance P, of course, is this one, right? Variance S will be this one. Is that okay? So let's see the example. Is that okay? Is that clear? So take the square root, okay? And why you want to take a square root? Because to make the same unit, okay? That is the only reason to take the same unit. Because you square, you want to go back. Just take the square root. And because of the square root, so the adjustment factor will be n over n minus 1, and that's it, okay? So there's nothing deep here. So let's talk about an additional refinement. After you take the square root, okay? You also want to divide it by its own mean, right? X bar is a mean, okay? X bar is a mean, okay? And usually also multiply by 100, okay? That is the usual formula you have, okay? Same for the sample counterpart, this one, okay? And the reason why you want to do this is because of you don't want to affect it by the mean, okay? And the reason why you want to do that because there are different ways to do the measurement unit, okay? You can measure the things in thousands or in millions, right? So if you want to compare the two data sets, whether they have same variability, you don't want to be affected by the measurement unit. So you divide it by the sample mean, then that's how what we call the coefficient of variation CV. Okay, so there's nothing new here. Let's see if I can look at this example, then we will break. Okay, let's look at the example and then we'll break. So the data we have 1, 2, 3, 4, 5. That's all one. So it's we have 2 to 7. Okay, so the mean is 4.5. Okay, actually same as the median. In the mode, in this case, it would be 2, 4, 3, 5, 6, 7. Everything's mode, and then it's 6 because 6 number of data. Okay. Although we don't show, but you can easily do the calculation and check the variance, the sample variance, standard deviation, right? So let me write down a little bit formula how you calculate this one, right? So how you get this one is 2 minus 4.5, okay? Square, 3 minus 4.5 square. You do for everything until you get 7 minus 4.5 square and divided by 6 will give you this answer. And if you instead divide by 5, will give you this answer. Okay, you take a square root, give you this answer. You take another square root, will give you this answer. Okay, and population CV will be this divided by the mean, give you this, right? And this divided by the X bar will give you this guy. Okay, let's have a break. And during the break, if you want, you can check yourself whether you understand this concept. Let's a break of 15 minutes. So we will resume at 1:36, 1:30, 1:32. Okay, but I will be around to answer the question you might have. You may open your mic if you want to, but otherwise you type. Information is just basically same as the variance and standard deviation, but you normalize by the mean, right? Because say usually you try to compare two data set, and CV is just standard deviation, but you just divide by the mean. Just know also the measure. Okay, you can say CV is also a measure of. So let me clean this out. CV is also the measure of dispersion. So that's the same thing. But why you want to divide by the mean? Okay, by the mean as the following. So suppose the data, okay, one data set is like this. Okay, and look at the other data set. Okay, it's like this. Okay, you would say these data actually have same dispersion, right? Right? Then you should say, oh, they should have the same standard deviation, but not. This one, sorry, these two actually have the same standard deviation. Okay, but suppose this is a okay, maybe I put it this way. Maybe I put a number. Okay, you have 1, 2, 3, 4, 5. Okay, and the other data is 1, 10, 20, 30, 40, 50. Okay, and obviously when you calculate the variance and standard deviation, this one will be larger, right? But you would think this is just a scaling times 10, right? So you really want to say, okay, shouldn't be affected by this, right? So that's why you want to say if you calculate the CV, they should be the same. Does it make sense to you? Chekwa? Is it Chekwa? I don't know. I can't really pronounce the name. Is that okay? I don't know whether I answer your question. Or you can unmute your mic and ask. I mean, of course, during the break, you are I mean, you're okay to use in Cantonese if you don't feel comfortable.
Professor Cole
啊，
我想問你可唔可以解釋多次IQR 嗰個第三個 method？
IQR 第三個，等等啊，我 clear 咗個 drawing 先。IQR 第三個 method 咧就係話你個 method 主要係用個quantile function 去做嘅。OK， 咁個 quantile function 個定義咧就係話 Q 嘅 P 啦，咁跟住就係 XK 咁呢嚿 function 啦，就係照背啫，咁冇特別啦。咁但係你話係點樣用？即係你係咪唔明㗎點用，定還是問佢點解咁嚟啊？
即係唔係好明點解咁用啊？
係。咁其實你唔係點用？咁其實你頭先講話 Q1 咧就係實際上 Q1 同 Q3咧就係1/4個 n 咁多 n 加一個位置 data 係嘛？咁呢個係4/3嘅 n 加個位置 data 啦。咁你點揾到1/4嘅 n 加個位置咧？譬如話呢個係譬如話3.5咁先算啦，係咪？咁譬如計出嚟譬如3.5啦，咁你係咪應該係3同4之間？咁應該 x 3.5係嘛？你點解3.5咧？咁你係咪用翻你中學時學過嘅數學啦？係嘛？咁3同4你假設佢係咁鬼長啦，咁你係咪要0.5呢嚿嘢？0.5呢嚿嘢
？X3係點樣
？X3係第三個數字咯。
哦，
即係譬如話你係有數字係譬如話，
即係我哋而家假設佢有4個數字咁樣。
譬如話有100個數字冇所謂嘅，第3同第4個數字。因為你係話 Q 係第3.5個數字啊嘛，係咪？咁第3.5個數字咁即係點啊？即係排好晒位，第3.5個。咁第3.5個點揾咧？就係3同4嘅中間嘅一半咯。如果佢係3.5嘅話，咁所以咪3.5 0.5即係等於0.5乘3 0.5乘 x4咁咯。呢個得唔得？
我消下先。
我咪再講一次，即係話譬如話3.5可能比較明，即係話如果佢係排，即係話如果你計出嚟 ，OK， 如果 Q1 計出嚟係3嘅，咁咪即係第三個數字啦，係咪？咁如果 Q1 計到4嘅，咁係咪第四個數字？咁但係如果即係第幾個數字啊嘛？如果 Q1 係話俾你聽第3.5個數字，咁你點辦咧？咁係咪應該係3同4嘅中間？咁所以咪一半嘅3，一半嘅4咯。所以咪 half x3 plus half x4。咁大家冇一半啫。咁如果唔係一半，咁點辦咧？即係話譬如話佢係3.75，咁點辦咧？咁3.75嘅話就咁揾啦，3、4。咁你學過3.75，咁即係呢邊係0.75係咪？咁即係呢個0.25係咪？咁咪即係你，如果你記得你如果學過呢個coordinate geometry 嘅話，你係0.25x3乘0.25 x4乘0.75咯，咁樣交叉乘嘅嘛。如果你記得教呢個即係如果你學過呢個數字，你記得呢個 coordinate geometry 嗰陣時叫你教你 x y 係嘛？如果呢個要 derive 1 minus alpha， 咁你咪揾翻出你直咪得你呢個啦。你呢個係應該係考試應該考過啦。考過，
不過年代有少少久遠。
係有啲久遠，但係一樣一個招就係，但係你唔理佢，你就咪照背條數咯。但係就係咁簡單啫。不過即係話，如果你想了解佢嘅來源，就係咁樣來源嚟咯。
算，唔該晒，唔該晒。
得唔得 ？O 唔 OK？
唔該晒。
你OK 嘛
？OK，
我哋再講清，再講一次。
好。
再講一次，你有咩問題？
應該 OK，唔該。
OK， 如果你有問題再問啦，唔緊要嘅。
好，唔該。
你可以係再問。請講。
我都想問咧，alpha 係咪其實可以係0㗎？
係啊，可以係0㗎。譬如話，如果咁啱計都係4咁，咪0咯。
哦，好啊，唔該。
係，如果有問題可以隨便發問。If your question you can ask。2.917。咁我 有學生有朋友就問下呢個問題啦，咁我就OK 有同學計到同我一樣嘅，咁可以大家交流下啦。你大家係咪想我計啊？但係通常我都係攞 Excel 出嚟倒出嚟嘅，咁我試下趁而家冇人，我去 Excel 啦。咁我而家未夠 Excel 啊，不過只係大家問下個問題，我就可以 show 一 show 啦。咁個數字就係2、3、4、5、6、7。咁 variance P 咁啦，2.967。係啦，冇錯，係2.917嘅，所以大家係計啱嘅。唔好意思啊，我呢個多謝大家提醒我，唔知點解抄錯咗啦。非常之好，證明大家係有做嘢嘅。唔好意思啊，第一次教嗰陣有啲 typo， 我有問題我要講翻。嗰個2.917，唔該晒，唔該晒。咁大家可以自己改翻。So if you figure out it's a problem, so please change your slides because of there's a typo over there. Do we need to remember all the formula for the tests and exams? The question is the quiz is kind of open book, right? It's fine. I mean, just because ask. Exam, I don't know because I'm not sure whether I can do open book. I have to check if open book is allowed, especially when if we resume the face-to-face, then I don't know whether we can do open book. But I don't know whether open book or closed book is better, because if open book, then the question will be more difficult, right? So I don't know whether you would prefer open and closed book. Yeah, but at the moment, so let's wait, because if they resume and other class also use closed book, then probably I use closed book. Just basically follow the others formula. Or if other class allow cheat sheet, then I allow cheat sheet. Then you don't even remember. So at the moment I can't tell you, because or maybe you can ask other section if they use open book or not open book, because I in office I can't see many colleagues, because many colleagues are teaching from home. So I come to office, I can't see anyone. So I don't know. So maybe I ask later. Is that okay, Kaka? Maybe you can ask me a few class later. Is that fine? Yeah, you ask me that later. But if good, you can ask other classmates from other section, and then we can decide.
唔好意思，我想問可唔可以即係又係去翻嗰個 IQL 嗰度 method？
OK， 冇問題。
嗰個可唔可以用文字去到解釋佢？因為頭先你講嗰個咩？
即係呢個你定係還是淨係 IQL 呢嚿嘢
？IQL 嗰個 method，
即係呢個
method 3。
OK，method 3其實好簡單，即係話咧，你其實係揾翻呢個嘢嘛，第四分一個 n+1 嘅 grand 嘅數字係咪？即係嗱 ，Q2 其實就係第中間嗰個啦，係咪？呢個 OK 先。
嗯。
OK， 即係基本上咧就係你嘅揾法咧就係，即係我再講一次啦，不厭，即係你覺得唔好怕煩啦，講一次啦。咁你基本上嘅數字係咁多啦嚇，啲數字喺度啦。咁呢個最大，呢個最細，呢個最大啦。咁中間就係 Q2 啦，即係叫 median 啦，係咪？
嗯。
咁 median 嘅定義我哋就係1/2嘅 n 加1，第1/2嘅 n 嘅啫 ，x 嘅1/2嘅 n 加1個位啦，係咪？
係。
咁如果你係 Q1 嘅話，我哋就會話係第1/4嘅 n 加1咁多個位啦，係咪？ 咁如果呢個係整數嘅話咧，咁就冇問題啦，係咪？如果係整數嘅話，咁就好簡單啦。如果呢個譬如話321咁咪如果係嘅3嘅咪第三個數字咯。如果2嘅整數係第二個數字咯，係咪？呢個 OK 嘛？咁但係如果呢個唔係整數嘅話，係一個點數嘅話，譬如話，如果佢係計出嚟呢嚿嘢係譬如話3.7，咁點辦咧？3.7，譬如3.75咁點辦咧？係咪？咁第3.75個數字係咩咧？咁你如果第三計3.75嘅話，我哋通常係即係話咩咧？即係話第三個數字同第四個數字嘅中間啦，係咪？喺一個唔知邊度中間啦。但係3.75嗰個咪應該係近啲4啊？係咪3.75？咁我哋點樣去做呢個3.75咧？我哋就係一個叫做 linear approach，就 linear interpolation。OK， 咁即係點咧？3.75即係話你呢度咧就佔0.25份，呢度咪0.75份咁樣，即係話呢度係3/4，呢咪1/4，啱唔啱？咁個做法就係話你呢度佔咁多，佔多，咁點樣計咗呢個中間係咩咧？係咪？要點計咧？咁嘅話咧，你就會用 interpolation 嘅辦法咧，就係話呢嚿嘢乘呢個，同埋呢個乘呢個 ，OK？ 咁你可能話 OK， 我都唔係好知點解咁喎。咁你可以諗翻畫翻個圖啦嚇 ，x y 呢度0到1，咁呢度咧就係4/3啦。OK， 呢邊4/3啦，咁即係呢邊1/4啦。OK， 咁 x3係幾高咧 ？x3 係呢度啦嚇 ，x3 就係呢個位 ，x4 就係呢個位。OK， 咁你畫一條線喺度。OK， 咁我想計翻呢個位 ，sorry， 唔好意思啊，呢度畫錯咗添。我再畫過，唔好意思 ，sorry。sorry 啊，0呢個位就 x3就喺度啦，咁高。OK， 呢個位就 x4。OK， 你又呢度畫條線喺度啦。咁你想呢度畫條線上去，咁呢個係乜鬼嘢咧？咁呢個就 x 係3.75係咪？咁點揾呢個點咧？咁咪就係個公式就係咁啦。x3 1/4個 x3 再加1/4嘅 x3 4/4 x4。呢個係你記唔記得學過呢個？
記得。
就係呢嚿嘢咯，就係咁樣計出嚟，就係畫翻呢個，就係畫翻呢幅圖出嚟 ，interpolation 出嚟。
但係我唔明呢個同嗰條式有咩關係啊？即係喺條式嘅邊度？
呢個點樣揾 x 嘅3？呢個就 x 嘅3.75啊嘛。即係話如果你畫嗰條線就係咁樣揾出嚟嘅。即係話3同4，你就係0，呢個 x3就係呢個0呢個位啦 ，x4就1呢個位啦。咁你3.75咪就係4/3呢個位，點樣揾翻第4份？即係中間你 cut 翻開4/3份，咁就係條式就咁樣嚟咯。你如果其實如果唔記得嘅話，呢個咪就係一個三角形嘅，係嘛？如果你記得嘅話，即係話如果呢個係一個叫 similar triangle 嘅問題嘅，即係你可以寫成 x 減3.75減 x3 over x4 減 x3 等於睇你1/3，得唔得啊？呢個咁你 rearrange 就係得到你嘅公式咯。呢個係一個幾何嘅問題啦。如果你唔記得嘅話，就係一個相似三角形。但係其實你可以唔使理嘅，不過如果你咁問，我就解釋翻俾你聽。
OK，
即係你得唔得啊？
呢一度我諗大概明咗啲。
唔緊要，呢個唔係喺我哋嘅考試範圍，我唔會問呢個 formula 點解嘅。不過我淨係想話俾你知，就知道就好點解。
唔該。
個原理咁解啫。Okay. Are there still no questions? If no, then we just resume. Okay, so we go back to so we finished the deviation. Okay, so now let's talk about shapes. So we know the measurement of the central tendency, which is mean, median, mode, right? And measure how accurate the mean, median, mode, right, is to talk about the range, interquartile range, variance, standard deviation, and coefficient of variation, right? And actually, there are more measures. You can go ahead, right, to see. First, there are two things we really care in our data. First is the symmetry data, is how skewed the data is. And the other is whether the data is have a very fat tail or a short tail. Okay, why we care about these two? Actually, these two are actually arise in practice a lot. Okay, skew. The data is skew means that is whether is how relationship between mean and median. Basically, is relationship between mean and median. And somewhat, if the data is skewed to the left and skewed to the right, then it just try to help us to see how useful is the mean and the median can predict. Okay, so let me go to the detail, and then probably you will be with the graph, it'll be easier to see. Let's go to the graph first. Okay, if the data is symmetric, okay, have a single peak, then we have same mean, median, and mode. Okay, that means that actually. Oh, sorry. We're talking about the shape. So, whether skewness of the data or the kurtosis. Okay. So can you see this PPT? Yes, right? Okay. So look at the graph here. If the graph here is how skewed the data, right? If this is not skewed, it's symmetric. The mean and the median and the mode are the same. Okay. And if this is positively skewed, okay, then the median will be below the mean. Okay. So why this is common? Actually, this is common in the income data. Okay, because you know that a lot of rich people is earning much more. So that's why the in this case median will be better than the mean. Okay, so what does that mean is your data is positively skewed, you should use the median. And very often that you will report the skewness of the data. Okay, and how to measure skewness we will tell you very soon, but this is how we calculate. That's why when we talk about the income, we look at the median income. You don't look at the mean. Okay. If you other way around, if the median is above the mean, okay, that means there's a lot of thing below. Okay. And this is less commonly you would observe, but mainly usually you will see this positive skew. I can't recall what do we see when you have the this kind of thing, but most likely you will see the positive skew. Maybe there's somewhat of a, I just can't figure out the example. But how to calculate the skew? So the skew is something very simple, okay? And basically you can see example is the skew is very close to standard deviation variance, but you raise to the power 3. Okay? And you normalize it by 3 times of the variance, standard deviation. Okay? So sigma. Sigma is this guy. Okay? And actually for our purpose, right, we just care about the positive, negative. Then actually this doesn't really matter. Okay? Whether you divide it by 3 doesn't really matter. But anyway, but why you want to divide by 3? Because you don't want to affect it by the its variability. Okay, you just care about the skewness, so divide by 3. This is the way to normalize things, the standard practice. And this is try to measure. You can imagine this is you want to know this is because of whether the mean is a good measurement. Okay, if the skew is very little, then whether you look at the mean and median are good. Okay, we realize the data is not so skewed, but data is very skewed, then you prefer to use the median. That's the idea why you want to care about the median. So care about the skewness. Is that clear? Oh, how do you see the left skew, right skew? Okay, if your data, you calculate this. And of course, historically, you know the income data is right skew, right? Because you know it. So basically coming from historical data, you would know something is a right skew or left skew. But before you do anything, you don't know. Okay, you don't know. But you report this data, the sample one, then you try to estimate. Is that clear? Peter? Is that fine? And this one is a little bit somewhat interesting is the adjustment will be a very funny part. Okay. So the adjustment factor is not something very simple. It's a little bit crazy. I mean, I would say. I mean, I will never remember that part. Okay. By the way, I mean, I just forgot to mention, when you see this as a graded area, is something graded box is something more technical thing, which I'm not expecting you to memorize anything from the gray one, probably except the interquartile range. Usually the gray one is more like a technical thing. It's more complicated. So I will not expect you to reproduce this kind of proof. So, and the blue color box will be representing the thing that is important. Okay. So since this is an adjustment factor, sometimes you can calculate in this way. Okay. You may ask why I need to show you all this formula. It is because the software Excel or R or whatever package, sometimes they give you the population version, sometimes they give you the sample version, and the sample version sometimes vary a lot. Okay, and this is the formula if you want to scale it from scratch. Okay, or the formula we have here. So you need to know what the formula actually they use. It's the same as the IQR I mentioned, right? You need to know what actually the formula behind the software give you. Otherwise, that's a problem. But okay, but anyway, we are not doing calculation on this, but you need to know, I let you know this is the formula. I think you do the Excel, you will see. So the next one is called kurtosis. Okay, the skewness is actually mentioning how the mean and the median. Okay, and the reason why we care about this is if we always look at the data is skewed, then we should care about the median rather than the mean. Okay, although the mean is very important, but probably when you take the skewed data, then probably you should take the median into considerably more. Okay, so that's why you have several measures of center tendency. And the kurtosis, which is talking about, okay, the thickness of tail. Okay, and you look at the textbook, they talk about the peak. Okay, and in fact, this is not right. It's more like the tail. Okay, and to see why you will see this kurtosis formula is just in fact very similar to the skewness. Skewness is 3, right? But here become 4. Definition of skewness. And you will see why this is talking about tail, because you can see raised to the power 4, right? Which means that if you suppose this is the mean is here, right? And the data, the further away from the mean, right, will get raised to the power 4, right? Raised to the power 4. When you raise to the power 4, if you're further away than raised to the power 4, then the effect of the power will expand a lot, right? So, but this standard deviation, right? You raise to the power square, right? And take a square root and raise to the power 4 again, right? So that means that you only take square first, add up all the thing and take the fourth power again. So it's not raised that much. So which means that the further away, then you will be much, much larger. Okay. So this idea behind kurtosis means that if you have very extreme value at the 2n, then you will have large kurtosis. Okay. And in some sense, kurtosis is more like the variance, but you're putting even more weight at the extreme point. Okay. It's more like the variance is measuring the average distance from the mean, right? So it's average everything out. All right. And now you are actually saying that if you even further away, I give you even more weight. Okay. You can imagine it's kind of weighted average distance from the mean, but you put more weight on more extreme value. Okay. It's another way of measuring variability. Does it make sense? Okay. So usually, let me talk about this particular point here. Is what we call the excess kurtosis. Okay, this is usually what we use. Is kurtosis minus 3. Okay, why minus 3? I'll explain now. And this is what I think. This is what usually you the Excel or the software give you. 1 minus 3. 3 is the normal distribution. Okay. At the moment, we don't tell what is normal, but the thing what we call the bell-shaped curve is called normal. Okay. And why it's called normal? Because later what we learn is called the central limit theorem. Central limit theorem. What it said is if a data generating process is rather general, okay, satisfy certain criteria, what you see is a bell shape, okay? But just forget about this part. You can say that's very common, that's why normal. Very common thing, the kurtosis, the bell shape is 3, okay? So if the kurtosis is 0, that means that the extreme point is more similar to 3, okay? And then you use a Roman explanation. It's called mesocurtic, okay? It's not a meso, but it's a middle idea. Okay. And if you more than 0, which is more than 3, it's called leptocritic. Then the tail is more fat, okay? Much more heavy tail. Okay. And if platocritic, it's called the thin tail, okay? So that is the two things. And very often why we care about the fat tail and thin tail. The reason why we care about fat tail and thin tail is related to risk. Okay, some of you are doing accounting or the finance, then you know the risk is very important. And when the thing is a fat tail, then you need to be very, very about. Okay, because that means the extreme thing can happen. right? Because the tail is fat, it's a fat tail, right? I mean, fat tail means suppose the extreme point, right? To extreme point, if the tail is fat, it's like this, okay? If the tail is thin, it will be something like this. Not very common. You see, this is called thin tail. This is called fat, right? Fat means the extreme point is very common. Little and crypto. Oh, sorry. That is a typo. Yeah, fence. That's L. Okay, little, yes. And someone asked me why different power of could explain different characteristic. Okay, and square actually. Okay, maybe Peter, I copy your question to the public because I think this is a very good question. So why the power, square, cubic, and fourth power can different characteristic? So square, as we see, is just like you penalize the long distance a lot, but anyway, it's just measuring how far away, further away, you give more punishment, okay? And you see the cubic to the power 3, right? And actually means that if away from the mean, positively, negatively, would be canceled out, okay? So that's why asking the symmetry, okay? And why you say I can't raise to the power 5, also you can, but we just, for calculation, 3 can do the job, we don't go to 5, that's the reason. That's just people commonly use. And actually raise to the power 5, actually some people you use it. It's not uncommon to people use 5, but some people would do it, but we don't know the meaning, but there is some meaning to it, but usually you don't go to 5. And 4, we know, looking at the fat tail, okay? And you ask, why don't we go to power 6 and 8? Actually, you can. There's some reason why we don't do it because of, later you learn from the chapter 3 to 4, is not always every distribution has the kurtosis and skewness. It's not always exists for certain type of mathematical distribution. It's not clear right now, but probably not right now, but the kurtosis and skewness and variance sometimes may not exist, okay? If you give me a mathematical distribution. So that's why how it explained. Is Peter, did I answer your question? Okay, I mean, of course, I mean, if you still want to know, but anyway, you will see later, probably you learn chapter 3 and 4, then probably you know. I refer you to learn what they call the Cauchy distribution. They will say there's no variance. I think you learn some, you can check Wikipedia, Cauchy distribution, if you want to know more about those kind of stuff, but it's a little bit advanced, but this is the one measurement. And of course, now you have computer, why don't you raise to the power 2.5? There are a lot of reasons, but historically, there's a reason why we use this. It's easy to calculate. So let's see the graph, okay? And actually someone asked me the email why the peak is different. Because in the textbook, you will see they write the red in the other way around, the red is much higher. So if you see a textbook, the dialectic, they will draw in this way. Let me draw it. You will see the textbook, they're drawing, oh, why the pen? So you see the textbook, then they draw in this way. Something like this. I hope it's okay. Sorry for my drawing. But as I said, this is about the tail, not the peak, okay? So there's no point talking about how the peak, look at the tail. You just look at the tail, then that's how the difference, okay? And if you learn later, this is what we call lithium sometimes student T. But anyway, it's not something we focus right now. But the idea why we care about this, how kurtosis is part of fat tail. And the fat tail, why is it care? As I said, whether the extreme event can happen. Okay, extreme event can happen. If extreme event happen, if you're finance, then you be careful, right? People said 2008, right? The financial crisis is because of people overlook this fat tail event. Okay, they underestimate the risk and they think it's not so risky. Okay, and the fat tail, if the thing follow fat tail kind of this distribution, then you have to be very careful when you do the thing. Probably you need to do some risk management, right? If you don't do, then you cover the mean, get the variance, you solve the problem, you think it's fine. Then when things happen, then you lose the money. Okay? Is that clear? Why we care or skewness and kurtosis? And so the kurtosis, usually you see the Excel will give you some, you actually give you the sample one. So that is this complicated object, okay? And if you put the kurtosis formula, give you actually this one so complicated thing, okay? And the reason why like this is later you will see this is what we call the sample counterpart, okay? It's what we call the beta measurement if you measure in this way. And you measure this very complicated formula. This is the formula you give it from Excel, okay? Excel will actually calculate this one. Okay, but I just put it there. If you want to calculate from scratch, this is how the Excel come up with the formula. Okay, I hope that's okay. There's nothing don't need to memorize this. Just I just try to tell you this is the formula, and later if you want to calculate from scratch, then you know how to do it. Okay, is that clear? Any question before we continue? Because after this we'll talk about measurement, how two variables are related, and that's end of our class. But is there any question? So we just learn. You mean this formula here? How we define this? So is it behind this, the kurtosis, why this is correct? The reason why you do in this way, what we call, actually you learn in the chapter 6, is called unbiasedness. Okay, but we can just brief you why this is the case. Unbiasedness means, remember we try to estimate the kurtosis or the skewness, okay? We want to measure this. And if you just, okay, the question is if you just plug in this formula, okay? Suppose you just do this, suppose in the practice, if you calculate based on this formula, okay? It's not a very good measure if you have sample size is small, okay? When sample size is big, then you don't is not really good one, okay? Kurtosis is not a really good one. And the reason why it's not a good one, because when a sample size is big, then it's not a nice property. Why? Because remember, you have a population here. It's something you want to study, okay? And every time you do sampling, which is you do sample 1, you might do sample 2, you might do sample 3, right? And using every sample, you come up with one kurtosis, one kurtosis, one kurtosis, okay? And what unbiasedness means that if you calculate the average of this thing, okay, it's actually same as what the overall population one is called unbiasedness, okay? What it means is, suppose this is the target, okay? This is arrow, right, target. You want to hit this point, okay? And unbiasedness means you may hit here, you may hit here, you may hit here. On average, you're hitting the target. That's called unbiasedness. if on average it's not hitting the target, then it's biased. So what it means is these formulas are on average hitting the target. If you use other formula, it's not going to hit the target. Okay, that's the idea. And same as skewness, why we need to multiply this, same idea. Same as why we have n-1 here. Okay, all the sample counterpart are just saying that if you try to estimate, if you keep on average, that will keep hit the target. But this unbiased concept we learned at topic number 6. So don't worry if you don't get it. And the question is whether you need to memorize all the formula. As I said, if this is too complicated, I'm not expecting you to reproduce. I mean, I'm probably not asking you to reproduce this thing, right? I mean, of course, no one can memorize all this formula, right? But I guess you should know the variance, right? This simple thing, okay? Variance and standard deviation, you should know how to do it. If complicated like, say, skewness or this kind of formula, if I need it, probably I will give you in the question paper so you can do it, okay? So I would say if the formula is rather simple, right, then I would expect you memorize, but something like this, I probably will give you, okay? But if open book, then you need to worry about this question. So probably you will be something that you will be maybe I think let me ask other colleagues, see if they don't allow open book, probably I will put a formula sheet at the end if you do the exam. So that's why probably you know what to memorize, what to not to memorize. But I guess I don't really memorization because it's not the goal of this class, right? It's applying in the practice. And what the tail means, tail is at the end, far end. Peter, you get it? It's the end. So what's the fin or what's the thick, right? You can see this. If the tail, the end point have very low probability, very light probability, then it's the fin. The red one is called fat, okay? And fat and fin actually compare to the normal, as we said. Normal is 3, okay? If fatter than normal, then it's fat. If thinner than normal, is fin. That's the idea. Okay, any question? Because these are very intuitive thing. It actually is very useful. Okay, and if you want to know give you some data, you want to know where the mean is, how accurate the mean is, right? And whether it's skew or whether it's fat tail, then the 4 items you put together can give you some idea how the data looks like without looking at the whole data set. Of course, if you look at this picture, then probably you know a lot, right? But sometimes you just look at the number, right? Then you want to compare to normal, and that's why we care, right? And as I said, tail, you would care if you are account or finance, you care the risk, whether they lot of risk or less of risk. That is the main thing. Is that okay? Any more questions? Okay, if no, then we go to the last part. That is actually not complicated, just some formula here related to variance, which we call covariance, and its normalized version, correlation coefficient, okay? The idea is very simple. It's a linear concept, okay? It's asking whether the data X and Y are moving in the same direction from the mean, okay? So look at the graph maybe, okay? This one, look at the graph, is easy, okay? And first you can see the mean of X is around here, right? It's the mean of X somewhere. And the mean of Y is here, right? And you will see, right? If the data are mainly here and here, right? Which means that if X above the mean, right? Y above the mean, if X below the mean on the right, X below the mean on this side, Y is below the mean, right? Then we will say they are positively related, okay? You can draw a line to represent, to try to say this of how they're related, right? And how to draw a line, actually what we learned in the last class is called regression, but we don't talk about this today. But actually this is the most important thing, one of the most important thing we learn in this class is regression, okay? But it's draw a line to represent all these points, okay? And this is called positively related linearly, okay? And on the other hand, so this is X bar, this is Y, maybe you see the next picture. So this next picture, if X is below the mean, at the same time Y is below the, okay, this is X above the mean, Y below the mean, okay? If X is below the mean, Y above the mean, right? They will call negative related, okay? So that is the main idea. Whether they're above the mean at the same time, or one is above and below, okay? We want to measure, we want to have some idea, right? It's downward sloping or upward sloping, okay? So that is how we come up with the formula like this. Okay, the formula is like this. So we look at above the mean is positive, right? If this order above the mean is also positive, right? Positive times positive gives you a positive number, okay? So if they're jointly positive, then it's positive, right? If they're jointly negative, again, they're positive, right? So which means that if they're all above the mean, right, multiply together, we're about positive, right? If one is positive, one negative, we give you negative, right? So that means that you add them all up, every observations, right? Then this can tell you how strongly, whether you want to use a upward sloping line or a downward sloping line, okay? And of course, it's divided by n because the n observation is average product deviation, okay? If you want the terminology, it would be average product of distance or square distance, sorry, square, sorry, not square, product distance from mean, okay? So the product, right, distance from mean, average divided by n. Okay, so that's the main idea. And count up n minus 1, as I said, it's a sample one. And why this case, I explained already, it's a unbiasedness concept, but usually the book doesn't explain to you, but anyway, later you know. Is there any question about this one? Is that okay? Any question about this part? Because this is somewhat, when I learned it, I figure out this is not that easy, but once you get the idea, that's fine. Is that okay? No? No question, okay. The next one is actually rather simple. It's just the same thing, but you divided them by each of the standard deviation, just normalize. And why we care about that? Because you want to avoid this scale. You want to make it between 0, -1, and 1. Okay. What it means is 1 is everything on the same line, indeed. Okay. -1 will be everything on the negative line. -1. Okay, this is 1. And 0 will be somewhat, you don't know what it is, then something will be 0. Something like that will be 0. Okay? It's more or less you cannot tell any relationship. Okay? And this is something we usually report to people, correlation coefficient. Okay? And unfortunately, there are no hard and fast rule to say whether they are strongly related or not. Okay? But usually we would say if more than 0.7, okay, we will say strong, okay? 0.7, 0.8, 0.9, that would be okay. Or -0.7, 0.8, 0.9 will be strong. If just 0.5, then it's not very strong, okay? Or 0.6 is okay. But usually you would say it's above 0.7, then probably you will say strong. But there's no rule can tell you what. Okay, but usually they compare the two different variables, right? Suppose you look at relationship between income and education, right? And probably maybe in Hong Kong, then the correlation is high. Okay, education reward a lot, right? The earning by blue collar job and the white collar job is a lot. But in say Australia or UK, then you will not see that much. Okay, so that would be correlation will less. Okay, so then you can compare. If you two data set from different country, then you can compare this. Okay, so you can usually you don't look at by itself, but usually compare different data set, then you can say a lot. But by itself usually is hard to tell. It's more like comparison, like kurtosis, skewness, somewhat. It's just like you compare data set. It's more useful. Anyway, this is just the formula. I'm not. There's nothing deep here, but just dividing it. Okay. And let's go to the, as I said, this positive, this negative. And the final slide is turn out to be, if you use the sample version, right? The sample version is n-1. I think I have that. Do I? The n-1 here. Okay. Divided by n-1. And remember, this is also divided by n-1. So they cancel out. So turn out to be very funny thing is only for this particular case, the sample version and population are the same. The sample correlation coefficient is same as the population one. Okay, so this is only interesting thing is there's no difference between the sample and the population version. And again, to repeat, this correlation coefficient is always between 0 and 1. Sorry, -1 and 1. So if you tell me correlation coefficient is 2, there's a problem. Okay, there's nothing. It's always between 0, -1 and 1. Okay, and this is how to measure the linear relationship. Okay, and why we care about this? We will learn this at the very last section, last topic 10, regression. Then we will come back to understand this because the main thing, one of the main thing of this class is trying to draw a line. Okay, how to draw this line and whether this line is a good fit. Okay, it's a nice fit. It's a good representation of this relationship. Will be given by this correlation coefficient. It's related. I mean, there are another measurement, but this R square is closely related to what we are trying to estimate. Okay. I guess we finished all the slide for topic 1. So next class, we do the quiz. And I think we should do some Excel, I guess, do some Excel and do prepare the Excel. If I have time, we do R. So we're a little bit behind the schedule, but I don't think it is a matter. We should be able to pick it up because the first class, we are a little bit spending time on the other issue, but I think we should be on schedule. But okay, I think we should end the class here. So any question? If no, then I will just wish you a nice weekend. I will. Yes, during the class, just ask you. As I said, quiz is just if you attempt based, right? When you do the thing, then you should be get the most of the credit. Okay, it's not if you don't worry about making a mistake. I just let you know. Oh, basically, it's using the U reply. You just basically next time it's just multiple choice. Yeah, that's MC. Just A, B, C, D, E, and you calculate. And as I said, you just try to make sure checking your knowledge. So don't over worry about that. It's only, I mean, quiz is only, and also participation is 10%, right? So it's a part of 10%. So more or less, and also we only take 8 out of the 10 highest mark, and also marks will be very generously given. As I said, I mean, unless you make all the mistake, otherwise you get almost all the credit. So don't worry about that part. I guess so. I mean, I think that would be the plan, but we'll try to cover that part, and then we'll probably at the beginning of the class just help you learn. So don't worry. You can just consider exercise. It's open book, so it's not going to be closed book. It's open book, open note, whatever. You can any question? Yeah. I mean, feel free to. Nice weekend. I mean, it's almost time. It's already past the time. So nice weekend. Thank you. I stay around, answer any question you might have.
Professor Go。
Yes。
我想問點解，即係我都係唔明點解3次方就係出 skewness， 有4次方就係出 kurtosis。
你可以5次方得㗎，不過即係3次方我哋話佢正同負會抵消咗啫嘛，即係唔會抵消咗。如果你2次唔抵消咗正同負嗰啲咯。
咁但係即係我唔明點解條 formula 係咁樣 derive 出嚟嘅咯。
嗰個係定義嚟啫嘛，冇乜特別原因嘅，即係佢一個話因為咁樣做啊方便，即係 variance 係咪覺得好正常咧？
係 variance 都理解到。
咁3次只係話佢係 raise to the power 3，咁但係你可以問點解唔係話 raise to power 5咁係嘛？你咪問呢個問題，點解唔係 raise to power 5？咁呢個只係話咁其實3同埋呢啲係有個原因，因為咁樣計咧係容易啲嘅。有原因即係話你學到第3堂嗰時會話俾你聽，譬如話你計3咧有啲 common 嘅 distribution 咧計咗出嚟係比較靚仔啲嘅，就係咁簡單。你明唔明個原因啊？即係話佢靚仔啲，但係冇乜原，即係呢個係大家係咁定義咁，大家咁用嘅啫。即係點解唔係5啊，唔係7啊咁大家咁用，即係佢主要係想計翻係咪即係左右係咪對稱啫。
即係我想問，即係點解即係呢條式就可以計，即係用個數字就可以判斷到佢係咪對稱？即係呢條式有啲咩？
譬如話，如果佢係對稱，咁佢0啊嘛。譬如話，如果呢個 metric 嘅話，咁佢呢個抵消咗噶嘛。即係你諗下，如果呢個係咁，呢個係咁，佢係等佢嘅話，咁咪抵消咗咯。係嘛？咁即係抵消咗啫嘛。咁佢點解你話要咁樣做？咁唔係5係咪應該遠啲？咁但係因為佢3，咁就係呢個係佢個咁樣做係會 measure 到，但係同 IQR 一樣啫。有好多種 measure 嘅方法，你去諗一個新嘅都冇問題嘅。但係佢只係咁樣做啫嘛，即係佢冇話特別原因，即係話呢個做法咧就簡單啲做到我哋想做嘅嘢，咁咪咁。咁但係每一個 measurement 都有 drawback 嘅，佢冇乜辦法話有一個統一嘅最好嘅嘢。咁但係呢個做到我哋想做嘅嘢咯，就係。
OK， 唔該晒。
做少培upload video. I think it's video upload, right? I think I record the class. So 我聽唔到你講，咁大聲少少。
因為我見到星期2嗰班好似仲未 upload 到上 Blackboard。
冇睇到咩？但係 Zoom 已經有咯。但係我睇點 upload。我望一望，我係第一次做，我 upload 下，冇問題。好。
同埋我想問下咧，點樣即係點解呢兩條式係一樣嘅？可唔可以解釋下？
邊兩條式？
你而家呢係呢兩個，左邊同右邊。
呢個係 sigma 嘅定義啫嘛。sigma 係 variance 嘛。sigma 呢個係睇翻前面嗰幅圖。sigma 係咁樣定義啫嘛。睇唔睇到？即係 square distance 然後 divide by n。呢個就係咁咯，sum of square distance。
OK， 唔該。
我想問下第34版嗰度咧。
OK， 係咪呢個？
咦，唔係晒。唔係嗰個 excess kurtosis。
冇問題。excess kurtosis 呢個。
係啊，我唔係太明點解 fat tail 會係 slender 咯，即係兩個意思唔係相反。
因為 slender 係代表佢嗰個 peak 係 slender， 即係佢個 peak 係瘦啲。但係佢以前係話點解咁講咧？佢之前定義係叫做係個 peak 嘅肥定係瘦嘅。但係實際上呢個唔係好啱嘅，最後發現應該係講緊個 tail 嘅嘢。
OK， 即係嗰個咩 slender broad middle 就唔使點樣理㗎啦。
唔使理嘅就係 fat tail 同埋 fat tail 同埋唔係 fat tail 就其實最簡單。其實我唔理啲英文，通常我哋 fat tail。
OK。
呢個係我咁樣寫，因為佢本書有咁寫，我解釋下俾你聽。
但係 fat tail 即係如果唔係睇個 graph， 即係如果純粹用文字表達佢嘅含義係啲咩？即係話嗰個 distribution 係 extreme 啲定係？即係
extreme 啲嘅地方好大咯。咁即係話嗰個 risk， 如果你係話 risk 嘅話，咁咪好大咯。即係話佢喺 extreme 嘅地方比較肥。
比較肥咁即係？
即係話佢話，譬如話你投資嘅話，譬如投資咁啦，咁呢度比較肥咁，咪即係有啲好大危險咯。譬如話佢可能可以賺好多錢，可以蝕好多錢嘅，咁你咪要注意佢嘅 risk 咯 ，management 佢嘅 risk 咯。
哦，OK， 因為嗰個啡色嗰條線就係貼近嗰度，咁佢就冇咁。
佢比較 normal 嘅啫嘛 ，normal 嗰隻 miso 就係話，譬如藍色呢個係 normal 嘅，佢大個 normal 咪即係危險個 normal 咯，或者係冇咁即係冇咁危險咁解咯。
哦，OK， 明白。
即係譬如話你中場計數嗰陣時，你係計 normal distribution 啊嘛。咁如果你計到佢哋嗰個 distribution 係比較肥嘅，咁你用 normal 計出嚟就危險啊，咁就唔好咁計，就要另外再計法咯，就係基本上就係咁樣用。如果佢係話唔係咁危險嘅，咁你用個 normal 嘅算式去做嗰啲 risk management，咁就冇乜問題嘅。主要係咁樣用法。
OK， 唔該。
好，so let's see if any more questions. No more question, then you can leave. I mean, because the class is over, but I just wait until if you have any questions.
Professor， 我想問下堂個 quiz 係咪考翻今日教嘅嘢？
係啊 ，open book 嘅就係教翻第一個。我其實唔係考嘅，即係睇下你識唔識，即係自己考，自己考翻自己啫。因為都係屬於 course evaluation 咁解，即係唔係話真係考，真係唔係考試嚟，即係叫做 quiz 咁解啫。
OK， 唔該曬。
嘅話，我係唔會答你問題，即係咁解啫。你做過應該嘅事，明白嘛？Okay, see you next week. So let's see whether you have still a problem. Let me know. Any more questions? If no, then I'll end this Zoom meeting. Hi, any more questions?
Hi, Professor Cole. Can you hear me clearly?
Yes, please.
Yeah. I do have a question. I don't know what's the difference between a sample counterpart and the sample variance and the population variance.
Oh, I see. This variance, if you look at the textbook or other thing, they will call population. This is the sample variance. This is called population variance. There's two ways to measure this.
So there's only
for
the sample variance. I see that the denominator is n-1.
Yes.
So how does it make sense?
Why n-1, right? You asked me, right?
Yeah.
Well, n-1 is, as I try to explain, it's somewhat we learned in the topic 6, it's called unbiasedness. Means that if you use this measure, on average, that we would get the right answer. That's what it means.
Oh.
If you use this,
a little bit weird.
It's not as good as this one if you are doing a small sample.
So you mean the sample variance applies to small size database?
So if n is small, okay, if n is small, okay, you want to estimate this guy, this is a better thing.
Oh, so if the sample size is small, the sample variance is better?
Yes.
Oh, I see.
But remember, you are measuring this guy, okay? You're using this to measure this guy on the population.
Oh, okay. Thank you.
Okay. Yes, any more questions? Menkit and Jizin and Dominic. Hi, are you around?
Thank you, Professor. See you next time.
Yeah, if no question, you can just leave because I want to make sure everyone no question, I just go. Is it? If no question, then you can feel free to leave because otherwise it's not very efficient, right? You can just ask.
Okay.
Jizing, do you have any question? Okay. So you are. Then I just switch off because I didn't see any question. It's okay? No? Then I just turn off.